Hey folks, Mr. Bullock here, and this lesson is on factoring. This will get you ready for the factoring parts on the new SAT, and we can find all our information at www.bbtestprep.com. So here we go. So factoring the GCF. So if you factor by the GCF, list all the factors of 72, 108, and 126. Okay, so when I list those, see all these numbers go into 20 or 72, so they're factors of 72. Similarly, here's factors of 108. Here's factors of 126. Okay, and then they all have lots of common factors. They all have ones, twos, threes, and sixes, but the greatest common factor, that's what GCF stands for, is that 18. So that's what the GCF is right there. Now there's other ways to do it. I think that's the quickest and easiest way to just remind you how to do it. And I know all of you guys should have done that before, so in one of your math classes if you're taking the SAT. All right, so find the GCF of these guys right here. Okay, so the biggest number that goes into 48 and 60 is 12. I'm going kind of fast just because otherwise we won't make it through this video here. So it's 12. So now of the letters, you guys, we got to find the least power of the common letters right there. So they both share some U's, so the smallest power of U's comes from here. They both share some V's, so the smallest power of V's comes from here. Now they both don't have W's, so we can't have W in the GCF right there. Okay, so the greatest common factor, the GCF, is going to be 12UV squared right there. Okay, all right, easy. Okay, now the first step of factoring is to pull out a GCF. So here, let's factor this. I can pull a 2 out of all of these, and the smallest power x comes from that. So we'll pull a 2x squared out. So we pull the x squared out and the 2, and then when we pull that out, you guys, we should be left with this. And then what you can do to check is just redistribute the 2x squared through, and when you do that, it'll take you back to the original problem right there. Okay, everybody's done that before. Let's try it with this one. All right, so we can pull out of the 10 and the 15 of 5, and then we can pull the 1a out and the 2b's out, and so it would be 5a squared, or ab squared, sorry. And so when you pull the 5ab squared out, so we pull a 5 out of that, we're left with 2. We pulled the a out, and we pulled a b squared out. There's 1b left right there. And then we pull the 5ab squared out of that. There's no more b squareds. And then 3 with one more a. Okay, so that's what this says right there. And again, if you just distributed that back through, it should take you back right there. All right, so the next step is to look for a difference of squares. Okay, so the word difference means you're going to have a subtraction sign in between them. And squares means numbers that are squares of another. Like 4 is 2 squared, 9 is 3 squared, so 1 is 1 squared. Those are all perfect squares. So when we factor squares, it'll look like this. There's two terms, there's a minus sign, and you got perfect squares. And they factor to x plus y, x minus y, the numbers that are being squared. One has a plus, one has a minus. Remember that? They go fast, you guys, okay? So we need to see these guys as being perfect squares. There's nice minus sign, so it's a different sign, so they're the difference of perfect squares. This is 3x quantity squared, and 4 is 2 squared. This one's a little harder to see with the variables. So a squared squared is a to the 4th, because we multiply those exponents right there. And then this is 5b squared. Okay, so over here, this is going to be 3x plus 2, 3x minus 2. Okay, and if you FOILed that out, it would get me back to that right there. Okay, this one's going to be 8a squared plus 5b, 8a squared minus 5b. And it doesn't matter if you put the minus first and the plus second. It doesn't matter. Okay, I don't know why. I'm just I like putting the plus first. Okay, on this one here, you guys, they're perfect squares, but it's not factored completely because we can always pull out the GCF first. So if we pull out a 4 first, a real tricky one right here. So I have this in my Algebra 2 classes, and kids get stumped on this because we're doing all the difference of squares, and they get that answer right there. But factor completely, pull the 4 out first, and then this is 4p squared squared, and this is 9 q to the 3rd squared. Okay, so then that's going to factor to, oh, come on there. Okay, so it's going to be 4, don't forget your GCF, and then 4p squared plus 3q squared, and then 4p squared minus 3q squared. Whoops, I should have put a minus in right there. Let me get that right there. Okay, so there it is right there. My bad. All right. So factoring quadratics of x squared plus bx plus c. Okay, notice there's a bx in there, and this is a 1x squared. So these are pretty easy. They go fast, you guys. So just think you're going to start off with parentheses, you guys, and then you're going to put x's in the beginning of them. And then what you do is you look for factors of this number that add to this number right here. Okay, so for example, here's a bunch right here. Notice these are all 1x squareds, and they got that bx. So here's the b, and this one is 17 right there. Okay, so let's go ahead and put the parentheses with x's in them. Okay, over here, factors of negative 24 that add to 5 are positive 8 times a negative 3. So put a plus 8 in one and a minus 3. Okay, over here, factors of 16 that add to 17 are 16 and 1. So they're both positive, plus 16 plus 1. See, you guys remember doing this, okay? Factors of negative 56 are negative that add to this right here, negative 1. There's an imaginary 1 right there. So it's going to be negative 8 times a positive 7. That gets me negative 56. Okay, over here, factors of negative 48 are 16 times a negative 3. So plus 16 minus 3. Okay, then we do factoring by grouping. Okay, so this technique is used when there's 4 terms, 4 monomials, and I'm going to use red and blue to show you what's happening here. Okay, so what you do is you pull out a GCF out of the first 2, and then pull out a GCF out of the second 2, and then you're going to be left with a common binomial. So how am I going to use these colors? So the common binomial is going to come out as 1, and we're going to be left with the 2 GCFs in the monomial. And you're thinking, what? Well, check this out. So we'll pull out the red GCF out of the first 2, and a red, usually different GCF out of the second 2. Sometimes it's not, but usually it is. And then you're going to be left with a common blue binomial. And then that blue binomial gets pulled out as 1, and you'll be left with the blue stuff times the red stuff. And I know you're still thinking, what? Let's try it with this one here. Okay, so out of these 2 guys, what can we pull out? Just pretend like these guys aren't here. Focus on these 2. I can pull a 2 and an x out. So watch, when I pull a 2x out, a red 2x, I'm left with the blue stuff inside. So when I pull the 2x out, I'm left with y. Pull a 2 out of 6 is 3. Pull the x out, we're left with 3z. Out of these 2 guys, now focus on these, we're going to pull a red 3 out. When we pull a red 3 out, we're going to be left with a blue y minus 3z. Now see, these guys are usually common, so we'll pull that common blue guy out. It becomes one blue guy, and you're left with the red stuff. So there's the answer right there. Works every time, you guys. Okay, check it out. Okay, so here, let's group these guys. Now watch out, that's a minus sign. So when I group these 2 guys, it's going to change that to a plus sign. So as soon as you put parentheses around that, this minus, now remember, if I just distributed this minus back through, it would become a minus 6xz, and then this minus would be a minus 9z. That's that right there. Okay, so as soon as you put parentheses on it, change that sign if that's a minus. Okay, all right, out of here, I can pull, looks like just a y out. So let's pull a red y out. Out of these 2 guys, this minus is going to come right here. Out of these 2 guys, we can, looks like a 3, and they both have a z. So let's pull out a red 3z. Okay, look, they have the same common blue binomial. So it comes out as one blue binomial, and you're left with the red stuff. Okay, all right, so then now that trick works when you're factoring ax squared plus bx plus c when there's a different number other than 1 in front of that. So this is how I teach this instead of guessing and checking. Okay, I'm not a guessing and checking method guy, you guys. I'm a ADD guy, and I get frustrated with not being able to find it fast enough. So anyway, so I'm going to use this polynomial as an example right here to demonstrate this process right here. So the first thing you do is in your head multiply this number times this number. 15 times 4 equals 60. So now we're going to focus on that number 60. And so we ask yourselves, think of what numbers of 60 that add to this 16 right here. Okay, well 60 is equal to 10 times 6, and 10 plus 6 equals 16 right there. Okay, you with me? So we multiplied these 2 guys equals 60, and then think, what factors of 60 add to that? Well, 10 times 6 adds to 16. So now, so you rewrite this guy by replacing this 16x with the 2 numbers that we got right here with 10x plus 6x. See, there's 16x. And look, we have 4 terms now. Now we just factor it by grouping right there. Okay, so I'm going to group them together. I can pull a 5x out, and I'll be left with 3x plus 2. Here we'll pull a 2 out, and we'll be left with 3x plus 2, and then bing, bang, boom, and you got it. Slam dunk. Works every time, you guys. It totally eliminates the guessing and checking. Now, if you're good at guessing and checking, please keep going with that. This is the way I teach it in my class, you guys. So let's try it with this. So 12 times 7 is 84. So then factors of 84 that add to negative 25, it might take you a second, but it's negative 21 and negative 4. So I put the negative 4 with the negative 12 because those are easier to GCF, but it doesn't matter. We can put the negative 21 over here if we wanted right here. And the 21 and 7 go together. Now I'm going to put these in parentheses, so since there's a minus sign, it's going to change that plus to a minus right there. You can pull a 4x out of both those guys, and you're left with 3x minus 1. You can pull a 7, 3x minus 1, and you got Bluey times Reddy. Okay, all right, factoring sums and differences of cubes. Okay, cubes are numbers like 1 cubed, 2 cubed, 3 cubed. So 1, 8, 27, 64. This is 4 cubed right here. 5 cubed is 125. 6 cubed is 216. So sums means there's a plus sign. Differences means there's a minus sign. So you'll see x cubed plus y cubed, x cubed minus y cubed. I had an Algebra 2 class, we kind of discovered this nice little trick right here. So when you got sums of cubes or difference of cubes, and they always go a binomial times a trinomial. So I like to say bi times tri, okay? And so then we go through the bi and tri, and we soap it, you guys. So we put the S in the bi, we put the O in the first part of the tri, and the AP go together in the last part of the tri. And the S stands for the same sign, so if it's a plus, then it's going to be a plus. O stands for opposite sign, and AP stands for always positive. Soap it. Okay, so here we go. X cubed plus y cubed. Bi times tri. Bi times tri when it's x cubed minus y cubed. Same sign, opposite sign, always positive. Okay, so if this is a plus, this is a plus. This is a minus, this is always plus. Okay, if this is a minus, same sign, so minus. Opposite sign, so plus. This one's always plus. Okay, so here we go. There's that right there. Okay, and let me slide that up right there. The bi part, you guys, are the numbers that are being cubed. So whatever's being cubed is x and y, goes here and here, okay? Then the tri part, you guys, the first part of the tri part is this guy squared. Okay, so square that, that goes here. Square that, that goes here. And think about it, you guys. If we FOILed this through, not FOIL or multiply, x times x squared would get me this x cubed right there. And then y times this y squared will get the y cubed right there. And then when you FOIL it all out, everything else cancels out, and you get that right there. Okay, so the first part is the x squared. The second part, or the last part, is the y squared. And then the middle part is just the product of x and y. So you just multiply that in the middle right there. All right, let's try that with this guy right here. Okay, so we need to recognize this is a cube, 2x cubed. This is 1 cubed. Here this is 4x quantity cubed. Here this is 3y squared quantity cubed, okay? All right, so remember powers to powers, you multiply them. So this one's a little tricky. You got to see that y squared cubed is y to the 6th right there, and 3 cubed is 27. Okay, so bi times tri on both of those right there. Bi times tri, and soap it. So same sign, opposite sign, always positive. Same sign. Whoops, this one's a minus. Golly. Oops, you can see my answer right there, okay? So that's a minus right there. And then always positive, okay? I got to change that right there, sorry. Little glitch right there. Okay, so same sign, opposite sign, always positive. Okay, so here, square 2x. So when I square 2x, that's going to be 4x squared. When I square 1, that's going to be 1. So I'm going to put that right there. So 4x squared and 1 go right there. And then you multiply. 2x times 1 is 2x. That's what goes in the middle right there. Okay, let me fix this little dude right here. Sorry. And then same, I'll just, let me go fast forward here and fix this guy right here. So, same sign, opposite sign, always positive, okay? So here's the 16x squared right here, because that's what this one is squared. Square this one, square that is 9. Y squared squared is y to the 4th, and then multiply this. 4x times 3y squared gets you that 12xy. All right, you guys? Okay, hope that helps. Take care.